Okay, hi folks. Right now we're up against Conrad's Head drumlin, and we're going to take a sort of a cursory look at the section first before we get into the sediment. But you can see a lot from a distance, so before you go to any quaternary section, you sort of want to take a larger view first before you make your observations, and then you'll be able to make more complete observations if you have some idea of what you're going to see. From your distance, you can see that there's a contact here. There's a different color sediment above than it is below. You can also see that at least this unit below the contact is very homogeneous. It doesn't have bedding, so there's no sedimentary structures that you can see. The clasts seem to be randomly distributed throughout. So it appears to be a diamicton. Some of you might have thought a gravel, but a gravel tends to have more sand. This clearly has a lot more silt, and it's very poorly sorted, meaning that it goes from clay and silt and sand to granules in the matrix, and the clasts are a very wide range, going from pebbles up to large boulders. So all of that, you can see that we have this diamicton and what looks to be another diamicton. Are these a landslide deposit, or are they tills or some other kind of diamicton? Well, that's where we're headed, but first we've got to look closer into the sediments. Okay, so now let's look at the sediment a little closer. I was just standing up at the contact above us, but right now let's see what things we should observe to characterize the depositional environment of this sediment. So first of all, we can't just look on the surface, because some of the material that we see may have been eroded from the top. So we want to dig in a little bit and make sure that we expose some fresh sediment. And what you'll see is a number of interesting things. First of all, as I break this, you can see that there's mostly matrix in here. Sometimes the matrix in these tills vary, but certain tills have a lot of silt. That will be important as you go through the lab write-up. Some tills are very sandy, but tills can be whatever the glacier flowed over. So if it has clay in the material before the glacier rode over it, then it's going to have clay in here now. This particular unit has what I would consider a clayey silt. It's mostly silt. There's some sand, but there is quite a lot of clay in here, and the clay is not deposited by soil, or formed by soil forming processes. So this would be clay that was already in the material at the base of the glacier, and it was mixed in, either offshore, but more likely, considering the ice flow directions, it would have come from over somewhere in central Nova Scotia. All right, so the matrix, the details on all of this, by the way, is in your lab write-up. But the matrix, if I can get a bit of a ribbon. Now, I'm not going to be able to get a ribbon, so there's not like more than 2% clay in here, but I can get a bit of a roll, R-O-L-L, roll. So there is some clay in here. Then what else is in there besides matrix? Well, there's lots of clasts. It's not class supported, but in some places the clasts are touching. It's mostly matrix, but the clasts are here. So what about the clasts? Well, some of the clasts are quite rounded. Some of them are very angular. Like this one right here is, as you can see, has very angular edges. That's an important observation. And actually, This one is striated as well. You can see maybe in the sun there, you can see some scratches on this clast. But others are quite rounded. You can see the edges of this one is rounded. And I can pull out, well, I can point to a few other ones rounding. So tills aren't made up of just angular clasts. Some tills are, and that tells us about the processes or the type of till that it is. But in this case, this has a great mixture of clast sizes and clast angularity, ranging from pretty much purely angular to, I would say, at least sub-rounded. Now, there's also something that you notice, and that's clast type or clast lithology. So if we were doing this for our work, we would count 50 cobbles here of a size somewhere around 5 centimeters or so in diameter. And we would go somewhere else and do another 50, and we would get enough data to characterize what the lithology of the clasts are for this area. I can tell you that most of it is metasediment, probably a lot from the Goldenville Formation, so lots of metasediments, but there's also lots of igneous as well. Lucamanza granites or whatever kinds of granite type lithologies are in the local plutons in the area. So this till is made up of clasts that have different origins, and that's going to tell us where did the till come from. And of course that will help us know where was the ice flowing at the time that it was depositing, eroding and depositing this till. Another thing to look for is, we said from a distance we couldn't see any large-scale structure, but do we see finer structures? So if you look, does anybody see any structure at all in this face? Well, for the most part, I don't see anything really, except if you scan the camera over here a little bit, you may be able to see that there is some facility. Facility is little partings or little fractures that occur naturally, not things that I'm making right here, like not that. But if you look in here, there's little partings that are natural when the material breaks off. And you've got to actually dig back in quite a ways in order to make sure that it's not related to shrinking and swelling of the surface as it's drying and wetting. We just had rain the last 2 days. But what you can see is that there are little partings. And you would spend some time looking at this to see if the partings weren't random, to see if that facility was somehow forming something that was a bit of uniform structure throughout the till. That could give you some hints into whether or not the glacier was moving its bed of till below it after it was deposited or during deposition. It also has been used to give some indications of how thick the glacier was and what the hydrological activity underneath the glacier was. Was it dry or was it wet based? So we don't have a strong facility here, but we definitely do have some little facility that allows the sediments to sort of break off into chunks instead of just loose granules. Another thing that I would look for when I look at tills is, are there any wisps of sand? So sometimes in a till, as you dig along, you can see little layers that indicate water had moved the sand, or at least sorted the sand. I'm not seeing that in here at all. I do see some color changes around clasts, but that's just normal. That could actually be periglacial activity when the ice was around here or when it was much colder than today. Like here, for example, it's just mud or Q10s that get formed in around the clasts. But I don't see any beds of sand or any laminations of sand that would indicate that when this till was deposited, there was sand being brought up and smoothed and sheared into that till as it's being formed. The last thing I guess that we should do is take a look at the color. We could actually use a Munsell soil chart or be sophisticated with our colors. Like in Marine Corps, they have different ways of conveying colors. But for us today, all we need to show is that yes, this unit here, this diamicton, seems different than the redder matrix diamicton above us. And we're going to visit that later. And all of this information, as I said, is in a table in your lab notes. So we just landed in the diamicton that was above the previous diamicton. The previous diamicton was a good example of a diamicton. It was pretty compact, massive, homogeneous. This one, I've come up from the contact by about 2 meters to get away from too much influence. If a glacier had rode over that lower diamicton, it would have incorporated some of the sediment, like the clays and other things. And also, if there was a soil between those two diamictons, I don't want to be in the soil here. I want to be in something that's more representative of this package of diamicton. So I don't know if you can see it in your light, but this is a lot redder than the other unit that we saw below. And as we go further up slope, it gets even redder. So there is some influence of the lower diamicton in here, which is a clue. We would kind of expect that if it's a till. But we're not going to interpret yet. We're just looking for sedimentary clues. The matrix is I would say, it does have similar facility, but it feels a little bit sandier. It's not as compact, so it's quite easy to break this stuff off. There are clasts in here, similar. I don't want to look at the surface, but the clasts do have, from my quick view right now, a similar kind of angularity, similar lithologies. It's a mixture of metasediments, especially metasandstones, but also some igneous rocks. And the only real difference in these two from a quick look is that the upper unit is a little sandier. I don't see any sandy wisps anywhere to indicate meltwater, but I do see plenty of facility, and there's a healthy component of clay in here as well. So it's a typical diamicton matrix with clay, silt, and sand. From the looks of it, and I know from other work that has been done here, the matrix is silt mostly, but some clay and some sand. Okay folks, so the helicopter has landed about another 12 meters or so above the previous site that we were at. And remember that previous site, that diamict had a red color, still quite a lot of clay, 2% is a lot. But it was a silty matrix, but loaded with mixed lithologies, granitoids, metasediments, but also even some volcanics and other things. But as we came up here, I noticed something really kind of cool, that first of all, the slope is different than what the slope was before. So you'll see that on Mike's nice side shots of the whole section. But there's also something even more interesting, and that's this, that In the lower part here, I still see granites and striated clasts. You can see a beautiful striated clast here, and here's a granitoid right here, and I see a mixture of different lithologies. But as I move up section, I'm losing the granite, and I've been up there before at other locations along this section, and you don't find striated clasts. So there are a few occasionally, but in some places in Nova Scotia, in the best examples, which are now mostly under houses or under golf courses or something, and we can't get to them, in the best example of that kind of till, there are only one kind of lithology in the clast, and it mimics the local bedrock, and there are no striations on the clasts. So here in this till unit, we seem to be influenced by going over an older till, or at least an older diamicton. If this is a landslide or if it's a till, it's still incorporating the stuff from below. And so that would explain the diminishing amount of granitoids as we get higher, and the fewer number of striated stones as we go up higher.